Welcome back to the mathematics class. So in the morning session, we have discussed the increasing, decreasing functions and also the rate of change of quantities, okay? So now we will continue with some more additional problems from these topics. Hope that all of you are hearing my voice. So shall we start? Okay. So let me start with the increasing, decreasing functions, okay? So in the morning, we have discussed about the increasing and decreasing functions. So using derivatives, how to determine a function increasing or decreasing? How to determine a function is increasing or decreasing? Okay, in which interval it is increasing and in which interval it is decreasing? So simply we have to find the derivative. Okay, simply we have to find the derivative of that function. Then when the derivative is positive, in that particular interval, the function will be strictly increasing. And when the derivative is negative, if f dash x is less than 0, in that interval, the function will be strictly decreasing. So this is the idea we have to use. Okay, that can be easily shown graphically also. You can see in this figure, in this means in the graph, there is a function very clearly. This function has some turning points. No? Very easily you can observe from the graph also where in which interval it is increasing and in which interval it is decreasing. Okay, very clearly -2. At -2, the function has a turning, and at okay, you can see at the point -2, when the point reaches at exactly at -2, you can see the tangent at that point is exactly parallel to the x-axis. Clearly, clear. At the point -2, the tangent is parallel to the x-axis. So what it indicates very clearly, the derivative at that point is 0. Okay. So -2 is a turning point in that graph actually. Okay. So actually we call -2 as a critical point where the function derivative is 0. Such a point is called a critical point where there is a turn. It may not be always differentiable also. A non-differentiable point of non-differentiability also can be a critical point. Okay, for example, mod x, etc. Mod x is not differentiable at the point of 0. You can see in the graph actually. But 0, at 0, there is a turning actually. At 0, the graph has a turning. So 0 is a turning point for mod x also. That is also a critical point. Okay, critical point means a function means the point where the derivative is 0 or the function is non-differentiable. The derivative does not exist. That is also called a critical point. Anyway, at this point -2, you can see the derivative is 0. That means the slope exactly you can see in the screen also m2 equals 0. Okay. And from the left side of that, what you can observe from the left side of -2, at any point, what is the slope value? Slope is positive. No? That means the function is increasing. Very clearly in the graph itself, you can see that the function is increasing nature. Okay. So if it is increasing means in that interval, everywhere the derivative will be positive. Okay. At -2, the derivative is 0. At -2, the derivative is 0. Then again, if you close -2, after that -2, you can see the derivative is, sorry, slope is negative. Yeah, derivative is negative. Now also the derivative is negative up to, yeah, this point. Okay, it may be 2.5. Sorry, 3 actually. Okay, in between 2 and 4. Middle. So at that point is also derivative is 0 actually. Okay. So that is also 3 is also a turning point actually. Eh? So minus 2 to plus 3. Minus 2 to plus 3. What is the nature of the function? The function is strictly decreasing. Okay. So how we can find using derivatives? You just find the derivative of that function and evaluate the value at any point in that particular interval. Okay. You can evaluate the derivative at any point, everywhere, either it may be positive or negative. So decreasing means throughout that in that domain, in that interval, minus 2 to plus 3, the derivative will be negative only. Okay. Now again you can see after crossing that point, you can see the function is of increasing nature now. Okay. So what is the slope of this function now? Everywhere you can see the slope. The slope value is already displayed here in the screen itself. At everywhere, the slope is positive. Okay. This is the way we are going to identify the interval where the function is increasing and where the function is decreasing. Okay. So this point you have to remember. Just I am showing to understand the concept actually. Okay. So this is the idea we have to use to determine a function is increasing or decreasing. So suppose C is a critical point, okay? Critical point means where the graph turns. That's the meaning of the critical point. That means either derivative can be 0, yeah, it may be a point of non-differentiability also. So once you know the critical point, if the left side, okay, from the left side of 0, sorry, that point, if the function derivative is negative means it is increasing, and derivative is positive means it is increasing. So what we have observed in the graph actually. So first thing is we have to find the critical point where the derivative is 0 or the function is not differentiable. So once you got that point, we will come to know the intervals actually. Okay, there may be more than one critical point also. Okay, C1, C2, C3 generally. So once you know the critical point, you just list out all the points and mark in the domain of that function. Okay, so you will get the different intervals. So in each interval, we have to check where the derivative is positive and where the derivative is negative. Okay, so that is the way we have to identify a function is increasing, strictly increasing or strictly decreasing. So let me take a an example. Suppose f of x equal to x cubed by 6, x cubed by 6 minus x square by 4 minus x square by 4 minus 3x minus 3x. This is the question, okay? F of x equal to x cubed by 6 minus x square by 4 minus 3x. X cubed by 6 minus x square by 4 minus 3x. So the question is find the intervals. Find the intervals in which the function is strictly increasing or strictly decreasing. Means both interval we have to find out, okay? This is the function. Actually, this is the function just I have shown to you. Okay, I have taken the same example. Whether we will get the same interval what we have observed in the graph. To check that, I have taken the same function. Okay, once again, I will check it. Okay, I will check it, confirm it. X cube by 6 minus x square by 4 minus 3x. Okay. So this is our function. So we have to find the intervals where this function increases and where this function decreases. Okay. So what we have to do? First, we have to find the derivative. Okay. First, find the derivative. That is f dash x. Everybody can find the derivative of this function. X cube by 6 means 3x square by 6. Derivative of x cube is 3x square. So 3x square by 6 minus derivative of x square by 4. What is derivative of x square by 4? 2x upon 4. Okay. Minus 3. So this can be further simplified. Let us simplify further. So what you will get? X square by 2 minus x by 2 minus 3. X square by 2 minus x by 2 minus 3, isn't it? Okay. So this can be further, I can modify x square minus x minus 6 all divided by 2. X square minus x minus 6 all divided by 2. Normal simplification only. Now again, we can factorize it. Okay, to get the critical point, we need to factorize this quadratic polynomial. So how can we factorize it? Anybody can do it very easily. You know? X square minus x minus 6. The coefficient of x is -1 means sum must be -1 and product must be -6. That means the two numbers very easily we can find -3 and +2. -3 into 2 is -6, -3 plus 2 is -1. So in that way, if I factorize the factors x minus 3 into x plus 2 all divided by 2. Whatever the function is there, you find the derivative. Okay, that's the first step. Find the derivative, and it is polynomial means most probably it will be possible to factorize. Now find the critical point. How to get the critical point? We equate the derivative equal to 0. No. Critical point means either the function is differentiable or otherwise, derivative equals 0, or the point where the function is non-differentiable. Very clearly it is differentiable function. So f dash x equals 0 implies when the derivative is 0, x minus 3 into x plus 2 must be 0. You know, x minus 3 into x plus 2 must be 0 means one critical point is 3 and the other critical point is -2. Means the derivative is 0 at -2 and other point is 3. Okay, so we got the critical point. Okay, that means these are the points where there may be a change or turning in the graph of the function. So once you get the critical point, the next step is we have to identify the intervals. Okay, how to get the intervals means the domain is all real numbers because it's a polynomial function. So domain is always all the real numbers. Okay, now we got -2 one critical point and 3 other critical points. So just roughly you mark these points in the order. Okay, -2 is less than 3, so definitely -2 must be first. After that you mark 3. So that means our domain is divided into how many intervals? 3 intervals. Okay, One interval is minus infinity to minus 2. Okay. Second interval is minus 2 to plus 3. And third interval is 3 to infinity. Okay. Now what is the next step? We have to identify in each interval f dash x, the sign of f dash x. If it is positive means, if it is greater than 0 means strictly increasing. If it is less than 0 means strictly decreasing. That's all. Okay. So there are three intervals. So in each interval, we will check the value of the derivative. If you want, we can write as a table the intervals and sign of f dash x, sign of the derivative. Okay. Let us make a table. So intervals minus infinity to minus 2. Okay. The second interval is minus 2 to plus 3. And third interval is 3 to infinity. So we have identified the intervals. Now our task is just to check whether derivative is positive or negative. Okay, in each interval. So how can we do that one? For that is very simple. You choose any value in that particular interval. Okay, any value in that particular interval, anyone. For example, minus infinity to minus 2. So I can choose minus 3. Minus 3 belongs to that interval. Minus 3 belongs to this interval. So just to calculate the f dash x at the point minus 3. Okay. So for that, refer our f dash x. What is f dash x? You can take this one, the factorized form. X minus 3 into x plus 2 divided by 2. X minus 3 into x plus 2 divided by 2. That is our derivative. X minus 3 into x plus 2 divided by 2. This is our derivative. Okay. This is our derivative. So derivative. Now we have to substitute minus 3 for x. So you just substitute minus 3. So if I take minus 3 for x, what you get? Minus 3 minus 3. Minus 3 minus 3 means minus 6. That is negative actually. Into minus 3 plus 2. Minus 3 plus 2 means that is negative 1. So this will be negative. This will be negative and this also will be negative. Anyway, we need the sign only. Okay. So f dash minus 3 means you will get some positive. First factor is positive. Sorry, negative. And second factor is also negative. Okay. Negative into negative. That means ultimately the derivative is positive. Now you go to the second interval, minus 2 to 3. In that interval, what is the sign of the derivative f dash x? Again, we are checking the sign of same derivative in this second interval. So minus 2 to 3. You can take any value in between minus 2 and 3. For example, I can take 0. 0 very clearly 0 belongs to that interval. Okay. So what is the sign of f dash x? I put x equal 0. You take any value in that interval. There is no need of taking 0 only. You can take 1 also. You can take 2 also, because all this belongs to the same interval. So put x equal 0. Put x equal 0 means 0 minus 3. That is negative. Then 0 plus 2, that is positive. No, first term is negative, x minus 3 is negative, and x plus 2 is positive. That means the product will be negative. Now the third interval. Third interval means 3 to infinity. 3 to infinity. Any value you can put in that interval. More than 3. That's all. Okay. You can put a 4. 4 belongs to this interval. So for x, you put 4 actually. Any value from that interval, I take 4 actually. So what is the sign then? X minus 3 means 4 minus 3. 4 minus 3 is positive very clearly. X plus 2. 4 plus 2. That is also positive. Okay, we don't record the exact value. We only need to check the sign. Okay, so positive into positive, that will give a positive. So we have identified each interval, and each interval we have checked the sign of the derivative also. Okay, so In the first interval, if derivative is greater than 0 means what's the meaning? The function is strictly increasing in minus infinity to minus 2. Like that, we have to write the conclusion, okay? Therefore, the function f of x is strictly increasing, strictly increasing in minus infinity to minus 2. There is one more interval actually where derivative is positive, that is 3 to infinity. So that also we can write together, okay? So f of x is strictly increasing in minus infinity to minus 2 and 3 to infinity. Yeah, union 3 to infinity. We can write in the language of sets, okay? Minus infinity to minus 2, union 3 to infinity. In both intervals, the derivative is positive, so the function is strictly increasing. So naturally, the remaining interval means minus 2 to 3. So in that interval, it is strictly decreasing. Okay, so f of x is strictly decreasing in the interval minus 2 to 3. So this is the method of finding the intervals. Okay, the same thing what we have experienced just before doing this problem actually. Okay, why I am showing this one now? To get the idea what we are doing. Okay, algebraically what we are doing, the geometrical representation. What is the meaning of that? Okay, so very clearly we can see that up to minus 2, the function is increasing. Okay, then minus 2 to 3, the function is decreasing. And from 3 to infinity, the function is again increasing. Okay, so that is very clear in the graph also. But we cannot do all these things in the exam time. Na? We cannot draw the graph and we cannot do any checking like this. Okay, so there comes the importance of the calculus. Without any graph, we can algebraically find the interval. So this is the procedure. Okay, whatever the function, the method is always same only. Okay. Now, if I include this in actually it is the open interval. Okay, minus 2 is not included actually. In 3 to infinity, 3 is not included. Okay. So if I include minus 2 also in this interval, then we say that it is increasing only, not strictly increasing. Okay. We have some result, some theorem like that. If a function is continuous in a closed interval and if it is the derivative is strictly positive in that corresponding open interval, then if you include that end point also, if you include the end point also to that interval, then we say the function is only increasing. Okay. That is not a big thing actually. So we can mention the interval where it is strictly increasing. But if I write what I am telling, if I write minus infinity to minus 2 in this way, so in this interval, we did not say strictly increasing, we say only increasing. Clear? Similarly, if I take 3 to infinity, 3 is also included. 3 to infinity, 3 is also included. Actually 3 is the turning point. At the point 3, derivative becomes 0 actually. Derivative is 0. Okay. So if I include that 3 also, we say simply the function is increasing in 3 to infinity. So let us write another question. Let us take f of x equal to sin x plus cos x, where 0 less than or equal to x less than or equal to 2 pi. The question is same. Find the intervals in which the function f of x is strictly increasing and also strictly decreasing. Okay, both intervals. So first I have taken an algebraic function, polynomial function. Now I have taken a trigonometric function. Okay, generally this type of two functions will be asked, either the polynomial function, algebraic function, or some trigonometric function. So same method actually. We have to find the intervals where this function is strictly increasing and where this function is strictly decreasing. Okay. So this is our function f of x equal to sin x plus cos x. All of you can find the derivative. First step is to find the derivative actually. So f of f dash x equal to cos x minus sin x. F dash x equal to cos x minus sin x. The next point is we have to find the critical point. Okay. That means f dash x equal 0. Let f dash x equal 0. So that means cos x minus sin x equal to 0. F dash x equal 0 means cos x minus sin x equal 0. And that implies cos x equal sin x and tan x equal 1, etc. And ultimately, what you will get? Cos x minus sin x equal 0. Otherwise, we can write cos x equal sin x. That means tan x equal 1. Okay. So what is the value of x? That's my question. Tan x equal to 1. So one value is very clearly pi by 4. No? Tan pi by 4 is 1. Tan 45 degrees is 1. All of you know. Okay. Tan pi by 4 is 1. Any other value? And one more thing we have to see. When trigonometric functions are given, there can be infinitely many number of points, critical points actually. At that time, we will not be able to write all the infinite intervals. So that is why some domain is given in the question itself. Okay. So we have to see only the critical point in the given interval, in the given specified interval. Okay. 0 to 2 pi. In that interval, what are the values of x satisfying tan x equal 1? So one value is pi by 4. Tan pi by 4 is 1. Everybody knows. No? Okay. Any other value? Anybody is having? Oh, let me check. Okay. The second value will be definitely how to get it actually. Sin x equal to cos x, that means tan x equal 1. Okay, tan x equal to 1. So tan x equal 1 means tan pi by 4 is 1. In the first quadrant, tan is positive. So definitely one value will be in the first quadrant, pi by 4. Now you know where tan is positive again. Tan x equal 1 means again tan must be positive. So tan, where it is positive, the basic trigonometry, you know, no? ASTC. First quadrant are positive. So tan is positive again in third quadrant. Okay, third quadrant tan is positive. So there is one value in the third quadrant. So that value will be definitely pi plus pi by 4. No? So third quadrant means it must be pi plus pi by 4. Okay, how it is getting, etc. Basic trigonometry only. I am not explaining all these things. Okay, if you take tan pi plus pi by 4, just I will tell. If you take tan pi plus pi by 4, tan pi plus pi by 4. So what is the answer? Third quadrant. Okay, tan is positive. So you will get a tan pi by 4 only. Tan pi by 4 means 1. So that's the way we are getting pi plus pi by 4. Okay. So pi plus pi by 4, that is again 5 pi by 4. One critical point is pi by 4. Another critical point is 5 pi by 4. In the given interval, 0 to 2 pi, in that specified interval, these are the two critical points, critical points. Now we have to identify the intervals. Okay. So how to do it? So we take only that interval. Okay. Here there is no need of drawing the whole real number. 0 to 2 pi is the given interval. Okay. 0 to 2 pi. Only that portion we have to see. And in that interval, you mark pi by 4 and 5 pi by 4, roughly like this. Pi by 4, then 5 pi by 4. So our given domain, yeah, given interval divided into 3 parts. You know? First part is what? 0 to pi by 4. Okay, 0 to pi by 4. And second part is pi by 4 to 5 pi by 4. And third interval is 5 pi by 4 to 2 pi. 5 pi by 4 to 2 pi. Okay. So we will write as earlier intervals. Intervals and the sign of what? F dash x. Okay. Remember, sign of f dash x we are going to check. So make it as a table. Okay. The first interval is 0 to pi by 4. 0 to pi by 4. And second interval is pi by 4 to 5 pi by 4. And third interval is 5 pi by 4 to 2 pi. 5 pi by 4 to 2 pi. Okay. Now in the first interval, 0 to pi by 4, what is the sign of f dash x? We need the sign of f dash x. Okay, f dash x. F dash x is actually what? Cos x minus sin x. No? Cos x minus sin x actually. So whether it is positive or negative, that is my question. How to identify this one is positive or negative? So same technique we can use. Okay. In that interval, you choose a value which is known. Okay. 0 to pi by 4 means in between 0 and 45 degree. In between 0 and 45 degree, there is a standard value, standard angle actually 30 degree. Na? That is pi by 6 actually in terms of radian. Okay, pi by 6. So just to take pi by 6. Okay, 30 degree will be in between pi by 6. So put x equal pi by 6. So what you will get f dash x, that is cos pi by 6 minus sin pi by 6. Okay. Cos pi by 6 means what? Root 3 by 2. And sin pi by 6 means what? 1 by 2. Root 3 by 2 minus 1 by 2 means very clearly it is positive. Is it clear? Root 3 by 2 minus 1 by 2. Root 3 by 2 is greater than 1 by 2. So very clearly the difference is positive. So we need only the sign actually. Okay, if I take in the first interval, the derivative is positive. Otherwise, also graphically, also we can identify whether it is positive or negative. Okay, if you remember the graph of sine and cos, okay, you know cos 0 is 1. Okay, cos 0 is 1 and cos pi by 2 up to pi, let us mark. Okay, 3 pi by 2 and up to 2 pi, I will mark. So cos 0 is 1 and cos pi by 4 is 1 by root 2 somewhere here, and cos pi by 2 is 0. Okay, and cos 2 pi is equal to, okay, I will draw in another way. Correctly, I will draw. Okay, 0, pi by 2, pi, 3 pi by 2, 2 pi. This is the interval, given interval now. So cos pi by 2 is 0, cos pi is negative 1, okay, cos 3 pi by 2 is 0, and cos 2 pi is 1. So the graph of cos x will be exactly like this, okay, clearly. This is the graph of cos x, okay. And graph of sin x, sin 0 is 0, and sin pi by 2 is 1, sin pi is 0, sin 3 pi by 2 is -1, and sin 2 pi is 0, this way. Actually, if you know the graph, easily you can find it. That's why I'm telling you, okay. The intersection point will be actually pi by 4. The both graph will be intersecting at the point pi by 4. No, we know sin pi by 4, cos pi by 4, both are same. No? 1 by root 2 actually. Okay. Now you see, in this interval, in the interval 0 to pi by 4, which graph is, which function is greater? Graphically, you can see, no? Which function is greater? Definitely, very clearly, cos x is greater than sin x. No? Cos x graph above, lies above actually. So cos x is greater than sin x. So in that way also, we can identify. That is what I want to tell you. Okay. So in the anyway, okay, somewhere the page where what we have written earlier, no, that is disappeared. Okay, anyway. So in the first interval is what? 0 to pi by 4. Okay, 0 to pi by 4. What is the sign of f dash x? F dash x is greater than 0. But anyway, you can check by any method, graphically also, by putting some value also. Now the second interval, the next interval is what? Pi by 4 to 5 pi by 4, isn't it? 5 pi by 4 to 5 pi by 4. Again, we will see the sign of f dash x. F dash x is same. F dash x is cos x minus sin x, okay? Cos x minus sin x. So how can we check the sign of f dash x in this interval? Pi by 4 to 5 pi by 4. The same method, same idea. Okay. In between pi by 4 and 5 pi by 4, you take a particular value. That's better actually. In between pi by 4 and 5 pi by 4, you can take pi by 2. No, more than pi by 4, less than 5 pi by 4 means you can take pi by 2. And just to find the value of f dash x, very clearly, cos pi by 2 minus sin pi by 2 actually. If I put pi by 2 for x, you will get the cos pi by 2 minus sin pi by 2. What is cos pi by 2? 0. What is sin pi by 2? 1. So 0 minus 1 means positive or negative? Negative, na? Yeah. You can take any value in that interval and put and substitute and verify. Okay. So f dash pi by 2 is less than 0. Now the third interval. What is the third interval? That is 5 pi by 4 to 2 pi. Clear? These are the three intervals we have already identified. Now in the third interval, 5 pi by 4 to 2 pi. You put any value in that interval. So which value can be taken? In between 5 pi by 4 and 2 pi. Let us take 3 pi by 2. Okay, 3 pi by 2 is in this interval actually. 3 pi by 2. You put 3 pi by 2 for x. Then see the sign. F dash of 3 pi by 2. Cos 3 pi by 2. What is cos 3 pi by 2? It is 0, na? 0. And what is sin 3 pi by 2? What is sin 3 pi by 2? Minus 1. Okay. So what you will get ultimately? 0 plus 1. And 0 plus 1 is what? Positive. Okay. Anyway, we have to identify the sign. For that, you take some particular value, non-value, so that we will easily, you can easily find out the sign actually. So in this way, in the first interval, the derivative is positive, and second interval, derivative is negative, and third interval, derivative is again positive. So clear? So 0 to pi by 4, this function is strictly increasing, and pi by 4 to 5 pi by 4, the function is strictly decreasing, and 5 pi by 4 to 2 pi, the function is strictly increasing. Okay? If any, okay, some responses are there. Sometimes I am unable to see your responses in between. Okay, anyway, some people have given the responses. The answer is here actually. Very good. Okay. Okay. So now I will take some more problems. In the morning also, you have asked some problems actually. No? So let me take some of the problems. Okay. We cannot do all the problems actually. The time constraint is there. So let us take some of the problems. Okay. Actually, somebody was asking in the morning session, tan 4x, tan x minus 4x. The function tan x minus 4x is strictly increasing on minus pi by 3 to plus pi by 3. Open interval minus pi by 3 to plus pi by 3. Prove that the function f of x is tan x minus 4x is strictly increasing. Okay, let us try. Okay, let us do this question. The function is tan x minus 4x. Okay, we have to prove that. One interval is given actually, minus pi by 3 to plus pi by 3. In that particular interval, this function is strictly decreasing. So let us find the derivative. Okay, f of x equal to tan x minus 4x. Tan x minus 4x. So what is f dash x? Everybody can write f dash x. F dash x equal to 6 square x minus 4. F dash x equal to 6 square x minus 4. Now, since the interval is given here, okay, minus pi by 3 to plus pi by 3, the question is prove that it is decreasing in this particular interval. Okay, so we have to show that in this interval, this derivative must be strictly less than 0. Okay, derivative must be negative in this given interval. That is the only thing we have to prove. Okay, since the interval is given there, directly we can do it. So derivative is 6 square x minus 4. We have to prove that this value is always negative in this given interval. Okay. So given that minus pi by 3 less than x less than pi by 3 means x belongs to this interval, minus pi by 3 to plus pi by 3. X belongs to this interval. If x belongs to this interval, what about cos x? If you know about cos x, then we can go to the sec x actually. You know? So what you can say about cos x? The cos x values must be in between. What are the boundaries for cos x then? You know, cos pi by 3. How much? Cos pi by 3 is cos 60, 1 by 2. Na? Minus pi by 3 is also. Cos minus pi by 3 is also 1 by 2 only. Cos pi by 3 is also 1 by 2 only. And cos 0 is 1. Okay, cos 0 is 1. That means cos x lies in between. Very easily you can say. Cos x must be lies in between 1 by 2 and 1. 1 by 2 and 1. I think it is clear. X lies between 0 minus pi by 3 and plus pi by 3. Okay. And we know cos pi by 3 is 1 by 2. Even cos minus pi by 3 is also 1 by 2 only. Okay. All negative values also, cos of negative x is same as cos x. And cos 0 is 1. Cos 0 is 1 means minimum value will be 1 by 2 and maximum value will be 1. So cos x, the value must be in between 1 by 2 and 1. Clear? If you know the graph of cos x also, we can say where cos x lies. Okay, when x is in between minus pi by 3 and plus pi by 3, what is the boundary interval for cos x actually? Okay. Now, if you know cos x, we can say about sec x. No? What about sec x then? Sec x belongs to which interval? Sec x belongs to, actually, if you take the reciprocal, 2 greater than 1 by cos x, that is sec x greater than 1. Okay. Yeah, sec x lies between 1 and 2. That's the meaning. 1 less than sec x less than 2. If cos x is in between 1 by 2 and 1, definitely sec x must be in between 1 and 2. Okay. Now what about sec square x? If sec x is in between 1 and 2, so what about sec square x? That lies between 1 and 4. Clear? If sec x is in between 1 and 2, the square of that value must be in between 1 and 4. Okay. So remember, sec square x value lies between 1 and 4, means less than 4 and greater than 1. So what about our derivative now? What is derivative actually? F dash x is sec square x minus 4. Okay. Now let us see this derivative. Okay. The f dash x equal to sec square x minus 4. And sec square x is a value less than 4. Okay. Sec square x is a value less than 4. So what about sec square x minus 4? Actually, sec square x, the value is less than 4. For example, maybe 3.9, just like, okay, 3.5 like that, less than 4. So the difference must be negative or positive. Very clearly, it must be negative only. That means f dash x is strictly less than 0. Okay, when x lies in the interval minus pi by 3 to plus pi by 3, we at last we got that sec square x minus 4 must be less than 0. So that means what? The function is strictly decreasing in that given interval, minus pi by 3 to plus pi by 3. Is it clear? Okay, now I will discuss some case study problems. Okay. Okay, before that, let us take this problem also. Show that the function f of x equal to 16 sin x divided by 4 plus cos x minus x is strictly decreasing in the interval pi by 2 to pi. Okay, this question. Show that the function f of x equal to 16 sin x divided by 4 plus cos x. So 4 plus cos x minus x is strictly decreasing in pi by 2 to pi. This is also asked in the last year board examination. Okay. A function is given, prove that it is strictly decreasing. Okay. I hope that visible. The question is visible to all of you. No? The function is 16 sin x by 4 plus cos x minus x. Okay, let us start. So let us find f dash x as usual. What is f dash x? Quotient rule apply. Apply the quotient rule first. So 4 plus cos x into derivative of 16 sin x means 16 cos x minus 16 sin x into derivative of 4 plus cos x, that is minus sin x all divided by 4 plus cos x the whole square. 4 plus cos x the whole square. Okay, the first part is over. Minus derivative of x, that is 1. Okay. Now you have to simplify further. We have to simplify further. Okay. Normal simplification. So what you will get? Remove the bracket. 4 into 16 cos x means 64 cos x. Cos x into 16 cos x means 16 cos square x. 16 cos square x. Minus into minus plus 16 sin square x all divided by 4 plus cos x whole square. 4 plus cos x whole square minus 1. Okay. And that's equal to 64 cos x plus 16 cos square x plus 16 sin square x means 16 into cos square x plus sin square x, that is 1. So 16 into 1 means 16 all divided by 4 plus cos x the whole square minus 1. Normal simplification only. Okay. You can also do. And finally, what we will get? So 64 cos x plus 16 minus 4 plus cos x whole square into 1. Normal cross multiplication. Okay. 4 plus cos x whole square all divided by 4 plus cos x whole square. And that is equal to 64 cos x plus 16 minus 4 plus cos x whole square. If you expand 16, 4 square is 16 minus of 8x, so 8 cos x minus cos square x all divided by 4 plus cos x the whole square. 4 plus cos x the whole square. Normal simplification only. Okay. So normal basic simplification techniques only. that is equal to 64 cos x minus 16 minus 16 cancel, okay? Minus 8 cos x. That also we can write at a time. So 64 cos x minus 8 cos x, that means 56 cos x, no? Minus cos square x all divided by 4 plus cos x the whole square. Finally, we are getting the expression in this way. Okay, so what we can do one more step, what we can do, cos x is common. Okay, take outside. The numerator, one cos x is common, take it outside. So cos x into 56 minus cos x all divided by 4 plus cos x the whole square. So this is our f dash x finally. After simplification, everybody can do, and all of you will get the same expression only, isn't it? Now we have to see what is the question actually. Prove that this function is strictly decreasing in pi by 2 to pi. In pi by 2 to pi. The given interval is pi by 2 to pi. In that interval, this is strictly decreasing. So how can you say that one? You check each and every expression, term of this expression. Everything depend upon this cos x actually. No? Everything depend upon this cos x only. Totally. The sign of f dash x depend upon cos x only. Why? 4 plus, the denominator is 4 plus cos x whole square. You know? That never negative actually. Okay, 4 plus cos x whole square means it is always positive only. Positive only. And 56 minus cos x. You know the cos x value is in between minus 1 and plus 1. Extreme values are minus 1 and plus 1. So whatever the value put for cos x, that means the value must be always minus 1 and plus 1. So 56 minus 1, yeah, 56 minus 1. Anyway, it is also positive. Okay. So except cos x, the remaining two terms are always positive. Okay. So what is remaining is cos x. So everything is depend upon cos x. Now you just tell me in the given interval. Okay. In the given interval, which interval is given? Pi by 2 to pi. Pi by 2 to pi. This is our given interval. In this interval, what is the sign of cos x? So everything is depend upon this cos x only. Now tell me what is the sign of cos x in this given interval pi by 2 to pi. The other terms are already positive. Okay, you just mentioned, you have tried like that. Okay, 4 plus cos x whole square is always greater than 0. 56 minus cos x is always greater than 0. Now everything is depend upon cos x only. So in this interval, what about cos x? Cos x is negative because second quadrant. Okay, in second quadrant, we know that cos x is negative. So cos x is negative means the derivative also must be negative. Okay. Therefore, f dash x is less than 0 in the given interval. Okay. In the given interval, pi by 2 to pi. So that means this function is strictly decreasing in this given interval pi by 2 to pi. Okay, one more problem I will discuss, and after that we will stop. Okay. Actually, this is a question from rate of change actually. Okay, rate of change. The case study question. Last year, it is in somewhere in some question paper. It is there in the last year examination. Okay. It is a very lengthy question actually. Some figure also is given there. I have not taken all those things. Okay. The question itself is one page actually. Case study means some figure may will be given. The question is like this. The main part of the question is like this. There is a tank actually. There is a tank. Okay, the figure will be figure actually given. I have not taken that part actually. One cylindrical portion and bottom is conical portion. Okay, that was the first part actually. There is a tank in this shape actually. Okay, a tap is connected to such a tank whose conical part is full of water. Okay, this tank, the conical portion is full of water. Water is dripping out from a tap at the bottom at the uniform rate of 2 centimeter cube per second. Okay, water is dripping out at the rate of 2 centimeter cube per second. And the semi-vertical angle of the conical tank is 45 degree. Semi-vertical angle of the conical tap is 45 degree. So this angle is 45 degree. So actually, this is the question. On the basis of the given information, answer the following questions. The first question is, find the volume of water in the tank in terms of its radius. That's the first question. Find the volume of this water inside the tank in terms of the radius. Okay. So radius can be taken as small r, and height of the conical tank, that can be taken as small h. Okay. So we have to express the volume in terms of the radius. That is the first part. So that can be done very easily. Just let us draw once again the figure. Okay, h, r, and this angle is 45 degree. This angle is 45 degree. And we know that volume of the tank means volume of the conical portion only. Volume of the water means the volume of the cone only. Volume of the cone means 1 by 3 pi r square h. 1 by 3 pi r square h. And that's equal to, we have to express this volume in terms of the radius only. Okay, in terms of the radius only. But you can see one h is also there. So for that, we have to apply some trigonometry here. Okay, if I apply in this figure tan 45 degree. So tan 45 degree is equal to r by h. Okay, that means 1 is equal to r by h. Tan 45 means 1. That means ultimately you will get r equal to h. So h equal r or r equal h. So that we have to substitute here. So r square into h is also r only. So that means you will get the volume as 1 by 3 pi r cube. So this is our first part. The first part of the question is, find the volume of the water in the tank in terms of its radius. So the volume is 1 by 3 pi r cube. 1 by 3 pi r cube. Okay. Now the second part. Find the rate of change of radius at an instant when r is equal to 2 root 2. Find the rate of change of the radius at an instant when r is equal to 2 root 2. Okay. So rate of change we have to find in the next second part. For that we have to differentiate, that's all. dv by dt. dv by dt is equal to 1 by 3 into 1 by 3 pi into 3r square into dr by dt. That means again we can modify as dv by dt is equal to pi r square into dr by dt. Okay, now dv by dt is given actually. dv by dt is given. What is the value of dv by dt? It is 2, 2 centimeter cube. So dv by dt is 2 actually. And the radius at the instant, the radius equal to 2 root 2. So the value of r is given 2 root 2. Okay. So value of r is given And value of dv by dt is also given. So we can substitute dv by dt and we can substitute r also, so that you will get the value of dr by dt. Okay. dv by dt is given. Okay. And r is also given. So substitute and find the value of dr by dt. Okay. That's the first part. The second part. I'm not giving the actual answer. You can do it. Okay. The third part, find the rate at which the wet surface of the conical tank is decreasing at an instant when the radius is 2 root 2. Find the rate at which the wet surface of the conical tank is decreasing at an instant when the radius is 2 root 2. So rate of change of the surface area actually required actually. Okay. Rate of change of the surface area of the cone. And we know the surface area formula, isn't it? The surface area, curved surface area actually, that is equal to pi r L. Okay, surface area is equal to pi r L. Okay, but again we have to replace this L. For that, what we have to do? The same trigonometry we have to apply. Okay, the slant height is L actually. So to get everything in terms of R, you connect R and L. For that, you apply some suitable trigonometry. So what we can do here, to get to connect L and R, we apply sine 45. Okay, sine 45 means R by L, and sine 45 means 1 by root 2. So 1 by root 2 is R by L. That means you will get L is equal to R root 2. L is equal to R root 2. So in place of L, we substitute R root 2. Okay, so what you will get? S equal to pi r square into root 2. Yeah, root 2 pi into r square. So we can differentiate, okay, ds by dr equal to 2 pi r into root 2 into dr by dt. Okay, from here, you will get the value of ds by dt. dr by dt already we got it in the first part. Okay, dr by dt. So that can be substituted here in place of dr by dt. So just I am telling the method, okay, because of the time constraint. Okay, the time is already over. So I think it is time to stop our class actually. Okay, so we will meet again at 6:30. At that time, we will discuss some more problems from these increasing functions and rate of change of quantities. Okay, for the time being, we will stop here. Okay. Eh? 3:30, na? 3:40. Eh? 3:40. Yesterday, okay, children. Actually, today I will take up to 4 o'clock. Okay. Earlier, I thought that the time is up to 3:30. Now it is informed that up to 4 o'clock I can take the class. Okay. So don't leave. Okay. So we'll take up to 4 o'clock. Time is there still? Okay, so I will discuss some more problems, okay? Okay, let us take this question. Water is dripping out from a conical funnel of semi-vertical angle pi by 4 at the rate of 2 centimeters square per second through a tiny hole at the vertex of the bottom. When the slant height of the cone is 4 centimeter, find the rate of decrease of the slant height of the water. Okay. Water is dripping out from a conical funnel of semi-vertical angle pi by 4 at the uniform rate of 2 centimeters square per 2 centimeter cube actually. Okay, it should be just 2 centimeter cube through a tiny hole at the vertex of the bottom. So when the slant height of the cone is 4 centimeter, find the rate of decrease of its slant height. Find the rate of decrease of the slant height of the water. This is also something which is similar to the previous question only. So let us draw a figure, a conical funnel. Okay, a conical funnel. Semi-vertical angle pi by 4, just like the previous question. Semi-vertical angle pi by 4. So we have to find the rate of decrease of the slant height of the cone. Okay, slant height of the water means slant height of the cone only. At the instant when the slant height is 4. So let us take the radius as r and height as h and the slant height as l. So as in the previous question, okay, what we have to, the volume of the cone is 1 by 3 pi r square h. Volume of the cone is 1 by 3 pi r square h. Okay. Now, this can be modified further 1 by 3 pi into, just like the previous question, we can connect r on h. Okay. If I take tan pi by 4, that is 1, tan pi by 4 equal to r by h. That means you will get r equal to h. Okay. R is equal to h. So you can put in place of h, I can put r. So that means you will get v is equal to 1 by 3 pi r cube. Okay. So what is dv by dt? So dv by dt is equal to 1 by 3 pi into 3 r square. That means actually pi r square into dr by dt. Pi r square into dr by dt. And dv by dt is given. Okay. dv by dt is given. Water is dripping at the uniform rate of 2 centimeter cube per second. So dv by dt is given, but r is not given here. Okay, we have to find dr by dt, but r is not given. So how to? In place of that, L is given. Okay, so we have to find the rate of change where L is given. What is L? L is given equal to 4 at the instant when L is equal to 4. Okay, so we know Pythagoras theorem. Let us apply Pythagoras theorem. We know that r square plus h square is equal to L square by Pythagoras theorem. Okay, r square plus h square equal to L square. And but r is equal to h. Okay, r is equal to h means you will get r square plus r square is equal to L square. R square plus r square is equal to L square. But L is given as 4. That means you will get 2r square is equal to 4 square. So that means you will get r square. R square is equal to 16. 16 by 2 and that's equal to 8. So when r is equal to 8 means r square equal to 8 means r is equal to root of 8. That's equal to 2 root 2. Okay. So that we can substitute here. So therefore, the previous equation, the dv by dt, substitute there. Okay. Equation 1 implies what you will get dv by dt, that is given as 2 in the question. Okay. dv by dt is given as 2. So 2 is equal to dv by dt pi r square. Pi r square means pi into r square means that is directly 8 into dr by dt. We substitute. Okay. dv by dt is pi r square into dr by dt. In that, if you substitute, you will get dv by dt is given as 2. Okay. So substitute. So you'll get 2 is equal to pi into 8 into dr by dt. So from that, you will get the value of dr by dt. So what is dr by dt? dr by dt is equal to 2 divided by 8 pi. 2 divided by 8 pi means 1 by 4 pi. Okay. So dr by dt is 1 by 4 pi. Now what we have to find is actually rate of change of the slant height. Okay. Slant height we have to find out. dl by dt. Actually, we have to find out. Okay. dl by dt. So how to get the value of dl by dt? So we know dr by dt. Okay. dr by dt is we got the value as 1 by 4 pi. Now using that, we have to find dl by dt. So we have to connect L and R. We have to connect L and R actually. What is the connection between L and R? So we know that sine pi by 4, that is 1 by root 2. And that's equal to R by L. Now we already got it actually. 1 by root 2. Sine 45 is equal to R by L. That means 1 by root 2 is equal to R by L. From that, what you will get? L is equal to R root 2. Okay. So we know that L is equal to root 2 R. Therefore, we have to find dl by dt. So what is dl by dt? Is that's equal to root 2 into dr by dt. So dl by dt is equal to root 2 into dr by dt. And that's equal to root 2 into dr by dt. dr by dt is equal to 1 by 4 pi. Okay. Using trigonometry, we are getting actually, okay, using trigonometry, we are getting L is equal to root 2R. Sin 45, if you apply, you will get L is equal to root 2R. So dl by dt is equal to root 2 into dr by dt. And dr by dt, already we got 1 by 4 pi. So substitute it so that you will, that can be simplified a little more. And that is the answer actually. Okay. This is another question. This is also asked in the last year CBSE board examination. Okay, very simple question actually. If f of x equal to a into tan x minus cot x, then find whether f of x is increasing or decreasing function in its domain. F of x is a into tan x minus cot x, okay, where a is positive, then find whether this function is increasing or decreasing in its domain, okay, wherever it is defined. So it's a simple question actually. Simply, we can differentiate. F of x is given as a into tan x minus cot x. A into tan x minus cot x. Then what is f dash x? F dash x equal to a into 6 square x minus derivative of cot x means minus cosec square x. Okay, that is equal to a into sec square x plus cosec square x. So this is the derivative of the given function a into tan x minus cot x, isn't it? So what can you say about this function actually? A is positive. Okay, given that a is positive, that is given in the question itself, a is greater than 0. And very clearly 6 square x and cosec square both are positive only. 6 square x means square is always positive only. So 6 square x is positive, cosec square x is positive. Yeah, 6 square x plus cosec square x is positive. That means the whole function f dash x is greater than 0. Okay, f dash x is greater than 0. That means it is a strictly increasing function. Okay, it is always strictly increasing. This is another question. This is also asked in the last year board examination. Okay. This is also from the rate of change of quantities, actually. Rate of change of quantities. A particle moves along the curve 3y equal to ax cube plus 1, such that at a point with x coordinate 1, at a point with x coordinate 1, y coordinate is changing twice as fast as x coordinate. Y coordinate is changing twice as fast as x coordinate. So find the value of A. A function, the moving path of a particle is given 3y is equal to ax cube plus 1. Okay, and the condition is x coordinate is 1 and y coordinate is changing twice as fast as the x coordinate. So what is the value of A? So what we have to do is we'll take the given function expression, that is 3y is equal to ax cube plus 1. 3y is equal to ax cube plus 1. Then differentiating, you will get 3 into dy by dx equal to a into derivative of x cube means 3x square. So 3ax square. 3 into dy by dx equal to 3 into ax square. Very simple differentiation only. Then 3 and 3 can be cancelled. So what you will get dy by dx equal to ax square. Dy by dx equal to ax square. Now what is given in the question? Y coordinate is changing twice as fast at x coordinate. So what is the meaning of that? Okay. So indirectly, what is given actually? Given that the rate of change of y with respect to x is equal to 2. Okay. The y coordinate is changing twice as fast as x means the value of dy by dx is equal to 2. Okay. So that means you will get 2 is equal to ax square. If you substitute for dy by dx, if you substitute 2, you will get 2 is equal to ax square. But also given that x coordinate is 1. Given that the x coordinate is 1. So substitute for x coordinate also. Also x equal to 1. Therefore, you will get 2 is equal to a into 1 square. That means a is equal to 2 only. Actually, it's a very simple question asked for 2 marks in the last year board examination. Okay. This is also a question asked in the last board examination. It is not from the rate of change of actually. Anyway, I have taken it. The equation of the path traced by a roller coaster is given by the polynomial f of x equal to a into x plus 9 into x plus 1 into x minus 3. If the roller coaster crosses y-axis at a point 0, minus 1, answer the following. Okay, means the equation of the path of the roller coaster is given by f of x equal to a into x plus 9 into x plus 1 into x minus 3. Okay. So question is, if the roller coaster crosses the y-axis at the point 0 minus 1, okay, at the point 0 minus 1, what is the value of A? Find the value of A and also find the f double dash x at x equal 1. So very simple question actually. No, very simple actually. No difficulty anywhere actually. Okay. Find the value of A. How to get the value of A? So what is given here? If the roller coaster crosses y-axis at a point 0 or minus 1. So x0 minus 1 means, okay, when x equal to 0, y is equal to minus 1. That's the meaning. No? When x equal to 0, y is equal to minus 1. You just put x equal to 0. Okay. When x equal to 0, the function value must be minus 1. That's the meaning. Okay. F of 0 is minus 1 in another way. F of 0 is minus 1. So very simply, you can put in place of x, you can put 0. Then f of x must be minus 1. Okay. So what you will get actually? If I substitute for x0 and f of x minus 1, very simply you will get the answer. F of x means minus 1. F of x means minus 1. So minus 1 is equal to a into x is 0. Okay, 0 plus 9 means 9 into 0 plus 1 means 1 into 0 minus 3 means minus 3. Okay, wherever x is there, put a 0. And f of x put a minus 1. That's all. Very simple question actually. Okay. So 9 into minus 3 minus 27. And so a is equal to minus 1 by minus 27. That is 1 by 27. That's the first part. Find the value of a. Now, second part is find f double dash x at x equal 1. Find f double dash x at x equal to 1. I think that is also very simple actually. There is no difficulty. Just you take the function and differentiate. Okay. So here it is itself I will write. Okay. Now what is f of x? A is a constant you can put later also. Okay. If I write f dash x, what is f dash x? Actually, it is a product of three functions actually. No? Product of 3. X plus 9 into x plus 1 into x minus 3. Either you can multiply, remove the bracket and make it a polynomial, then you can differentiate. Otherwise, directly also we can differentiate. Okay. So what you will get? A into, I think there is no need of explaining this differentiation actually. Everybody is familiar with this differentiation. Okay. A is a constant, you can take outside. Then you take any of the two together. X plus 9 into x plus 1. Okay, derivative of third one will be 1 only. X minus 3 derivative is 1 only. Plus the next term. Any two you can take together. X plus 1 into x minus 3. And derivative of first will be again 1 only. Plus, in that way, take any other two. Okay, x plus 1 into x minus 3. Sorry, x plus 9 into x minus 3. X plus 9 into x minus 3. And the derivative of third will be again 1 only. Okay, everything in bracket and outside the bracket, there is a constant a. Now, this is the first derivative actually. Okay, first derivative. So you can remove the bracket and make it a polynomial. Then we can find the second derivative. Otherwise, here itself we can again find the second derivative. Okay. After getting the second derivative, you put x equal to 1. Put x equal to 1. Okay. Okay, so I think we can stop here. Now it is 4 o'clock. Okay. So we will meet again in again at 6:30 p.m. Okay. So at that time we will discuss the remaining parts of this chapter, that is maxima, minima, and related problems. Okay, maxima, minima, and related problems from that area. That is also a very important area for case study and also for 5 marks questions actually. Okay.